till what is NPN, what is PNP, and we also understood how is the NPN transistor works and how the PNP transistor works. Okay, this is what was studied in the last class. So now in your syllabus, we have only two things. One is input characteristics and output characteristics of the NPN transistor. NPN, that too also common emitter, and transistor as an amplifier. That also is CE. Why CE? You have three type of transistor. One is CE, CB, and CC. Okay, for NPN. But in your syllabus, you have only CE and CB, CE only CE, and then we will study about logic gates. This is what is there in your syllabus. So we are left with three portions: input output characteristics of transistor, of NPN CE transistor, how is the transistor used as an amplifier, and what are logic gates. We'll study about AND gate, NAND gate, NOR gate, NOT gate, all that. Everybody is clear?
Yes, sir.
Okay. So coming to the first topic, that is input and output characteristics of a transistor. So in the last class I taught you how is the NPN transistor look like. How can we differentiate? You can differentiate NPN transistor by the help of an what? Arrow. Yes or no? This is the base, this is the emitter, and this is the collector. If the arrow is in this word, is a NPN. Now if you have arrow this way, then it is a what? PNP. Yes or no?
सर आपने उल्टा ड्रॉ किया शूज.
कैसे? अरे ठीक है यार, मतलब that's okay. You want here, no? You are saying right? इधर बोल रहे हो ना? Emitter, collector.
हाँ ये.
No, that's okay, no? See,
Okay.
any part, see the arrow part, that should be the emitter. That is what I'm trying to say. You can put this one emitter, you can, that is okay, immaterial. So arrow part, one is the arrow part, arrow should go inside, then it is emitter. And arrow should go outside, then that is emitter. So if going outside, I told you why is the arrow. What is the arrow? Caroline, why is the arrow? What does the arrow says? Huh? What does the arrow says? Yes?
Direction of the current.
Very good. Direction of current. Why? What about others? Why others can't speak? Others don't remember? Caroline? Harsh? Come on guys, answer. Am I audible, Siddhi?
Yes, sir. I was not sure about the answer.
What about why you're not able to sing the answer? You're not sure.
Yes, sir.
Why you're not sure, beta? Last class I taught you. Okay, so we will study the input and the output. First we'll study the circuit diagram. Let us draw the circuit diagram. Not so big. Draw with me.
okay. Okay.
So have you done everybody this figure? Yes, give me yes.
Yes, sir. Yes, sir.
So yes, sir. Who didn't understand what? Okay. So guys, this is a transistor, and this is a common emitter transistor. Okay. Common emitter, NPN common emitter. First of all, understood? And you see, this is the base, this is the emitter, and this is the collector. So the base and the emitter. So obviously, what is the emitter? Is it a N or a P? Emitter is a N or P? Hmm? Yes, guys. Emitter is a N junction or P junction?
N.
N. So now N is connected to the negative part of the battery. Yes or no? And this is the P junction. P is connected to the positive part of the battery. Is it forward biased or reverse biased? P is connected to the positive part of the battery. N is connected to the negative part of the battery. Is it forward biased or reverse biased? Forward bias. Understood? Yes or no, guys?
Yes, yes.
And
Yes, sir.
next is the collector part. The collector is connected to the positive part of the battery. So collector is again N part. So collector is N again. It is connected to the positive part. And next what? Next what? Emitter. Emitter is again N. No, not emitter. Let us consider base. Base is P. So P is connected to the, see the base. The base okay. The collector is connected to the M positive part. Yes or no? Huh? Yes.
Yes, sir.
And
Yes, sir.
so when the collector is connected to the positive part, is it a forward bias or a reverse bias? Reverse bias? N is connected to the positive part of the battery. It should be reverse bias. Yes
Reverse
or no?
bias.
So this is called active state. Remember, this is the this is how the transistor is working. The transistor active. Other, if you do other way around, if the emitter at base is connected to the forward reverse bias rather than forward biased, then the transistor will be in cut off mode. So this how the diagram should be, and this how you should do for the transistor to work. Is it clear, everybody? Yes.
Yes, sir.
Yes, sir. Otherwise clear? So first diagram, this is what you are going to write. First you have to explain. And R1, R2, what is this? Why this arrow is there? Why this arrow? What this arrow suggests? It is a what? Rheostat. Yes or no? What is rheostat? Variable?
Yes, sir.
Yes.
Resistance.
Yes. Variable resistance. That means there's something we are trying to vary here and here. Okay? Clear? And this battery, these two batteries are for what? For biasing. Yes or no? For biasing, we can say VBB. I'm sorry, VBB, because connected to base, and this is connected to collector VCC. So the two batteries VCC and VBB are for biasing. VBB is for base forward bias, and VCC is for collector reverse bias. Is it clear, everybody?
Yes, sir.
Yes, sir.
So I hope this is clear and you're noting down what I'm saying. This was you're going to write. And what are this? These are nothing but ammeter. Understood? Ammeter and voltmeter. Ammeter to measure the current and voltage. Understood? Yeah?
Yes, sir.
Microamp. See, here I put microamperes. Here it is milliampere. That means less current, more current here. Yes or no? Micro is what? 10 to the power minus 6. Milli is 10 to the power minus 3. Am I correct? So that means
Yes,
the
sir.
current here is very less. The current here is more. So I am not coming. I am yet to come to the topic. Please just note down whatever I am doing. And obviously IB, IC, and you also know that your IE is nothing but IB plus IC. Yes or no? Huh? So this
Yes, sir.
IB is going inside, this IC is going inside, and both are contributing to the I. That means this IE is the main current, which is contribution. Am I correct? Huh?
Yes.
So that's why the emitter is, I told you emitter is what? Area is more, because more and more current is flowing. Understood? Khula Maidan.
Yes, sir.
Hmm? So I hope that this thing is clear. So I have drawn it very big. The problem is I have to explain. When I'm explaining, I have to draw the diagram. So have you drawn the diagram in your copy?
Yes, sir.
Everybody, because I'm going to rub it.
Yes, sir.
Yes, sir.
Yes, sir.
Let me try to use another paint. Then I can reshuffle. Yeah. Okay. Fine. So first we'll study input characteristics. What is input characteristics of a transistor? So in the figure, what is input? What is given as input? Tell me. What is input? IB is input? Yes or no? Huh? This part, this part of the transistor is the input part, and the other part of the transistor is the output part. Yes or no? All of you.
Yes, sir.
Yes.
Hmm?
Yes,
So for input part, what you have to do? You have to find out the variation of IB, variation of IB, and IB is the input which is given as input. Yes or no? IB is the input. The variation of IB with respect to VBE. VBE. That means how is the current? How is the IB changing with VBE? That means if I change VBE, how the IB is changing? Is it clear? But
Yes.
what about VCE? This is the VCE. This VCE is kept. See, can you see 0 to 1 volt? Here I wrote, and here I wrote 0 to 10 volt. Can you see the difference? I wrote here 0 to 1 volt, and here I put 0 to 10 volt. That means input characteristic is how is the IB is changing with respect to VB at constant VCE. That means I am keeping the VCE, that VCE means this part, this voltage constant at, let's say, 1 volt, and I am changing VB. I am changing the VB I am changing, and with the change in VB, how is the IB changing? How is the IB changing? That is the input characteristics. Understood? Understood till now? So
Yes.
my
Yes, sir.
VC is constant at 1 volt, and next what I am doing, I am changing what? I am changing the VBE. Now change, you have to write like this. Change VBE. When you change VBE, what will happen? The IB also will change. Yes or no? Yes or no?
Yes, sir.
Yes, sir.
Huh? And this how we will plot the graph between the VBE, IB and VBE. So you will see that it will be like this. So this here it will be, let's say, 0.2, here it will be 0.4. So at 0.4, what is the current? Current is going exceptionally high, but this is for a fixed VC. This is VC is equal to 1 volt. Now I am changing VC. Now I am making it 2 volt. Then you will get like this. This is for this second is for VC is equal to 2 volt. I am again increasing VC now. Understood, guys? Understood, guys? So
Sir.
input characteristics is nothing
Yes, sir.
but the variation of IB with respect to VB at a constant VC. At a constant VC. See, this graph is for VC 1 volt. This graph is for VC 2 volt. This graph is VC 3 volt. Is it clear? Is it clear?
Yes, sir.
So every time I am increasing VC,
Yes, sir.
you see it is changing or not? You are getting set of like this, like this, like this, like this, like this, like this. So this is for one VC, this for another VC, this for another VC, this for another VC, this for another VC. Is it clear? Is it clear?
Yes, yes.
3 lines you have to write. You have to write first. What is input characteristics? Input characteristics nothing but the variation of IB or the input current or the base current with respect to VB. VB is the voltage between the base and the emitter. See, base, this is the base and this is the emitter. The what is the what is the what is the voltage between this one is called VB, which we can change it. How we can change? By changing the what? Rheostat. Yes or no? Rheostat, no. If I change rheostat, I am increasing the resistance. If I increase resistance, what will happen? The voltage will change.
Yes, yes, sir.
And similarly, how will I change VC? If I change this one, this resistance R2, here also if I change, then also I can change VC. Yes or no?
Yes, sir.
Advait, clear? Advait, Advait,
Sir, clear, sir.
good. So, and second line, you will say that we will change VC, we will change VBE. Okay, keeping what one VC constant at 1 volt, you will plot the graph. Now again you will change VC to 2 volt and you will change VB, you will get another graph. So this set of graphs is nothing but the input characteristics of a transistor. Clear? Done. This is what 5 marks. Is it clear?
Yes, sir. Yes, sir.
Now we will go to output characteristics. What is output characteristics? So write down the variation of collector current IC with respect to what? VCE. VCE is the collector emitter voltage at what? At constant base current, at IB is equal to constant, is called the output characteristics. Input characteristics is what? How IB versus VBE at constant VCE. Yes or no? Yes or no?
Yes.
But output characteristics is IC versus VCE at IB. constant. This is the input characteristics. This is the output characteristics. Clear? Clear, all of you?
Yes, sir.
Shall I rub it?
Yes.
Okay. Second, so this is the first question. First, the definition of IB. What would output characteristics? Then, keep the base current constant. I am keeping the base current constant. I am not changing. How is the base current we can keep constant? Yes. Who will tell me? How can you keep this constant? By keeping VBE constant? Yes or no? Yes or no? If I
Yes,
keep
sir.
this VBE constant, then only your IB will be constant. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
So I am keeping my VBE constant. So if I keep VBE constant, automatically your IB will become constant. And now what I am doing? So keep VB constant. Maybe I'll put something like 10 microamperes. And how can you measure? You can measure through the ammeter. Yes or no? Yes or no?
Yes, sir.
Yes, sir.
Ammeter is there. You can measure. So I am keeping 10 microamperes. So change the VB in such a way that you get 10 microamperes as the ammeter reading. So 10 microamperes, your IB is constant. Now what you do? You go here and change the rheostat here. Change the R2. When you change R2, what will happen? Your VCE will change. Yes or no?
Yes, sir.
And because your VCE will change, what will happen? IC is what? VCE by R. Yes or no? R2? Huh? Yes or no? VCE by R2 is IC. So you are changing VCE. When you are changing VCE, automatically IC will change. Yes or no? So with the changes of VCE, it will create a change in IC also. IC will also change. So hence the plot between the IC and the VCE is the output characteristic. So how will this will come like this? So this is for IB, maybe some value. If you increase IB, you will see this will increase like this. If you still further increase IB, so you'll get a set of parallel lines. Understood?
Yes, sir.
So that means what is happening? What is happening? It is increasing and then it is becoming constant. It is increasing and then your IC is constant. Increasing and then your IC is constant. Increasing and then your IC is constant. Understood or not? That means more the IB. Can you see? Here IB was constant, IC is constant. But if I change IB, is it not changing the IC? This is not zero, huh? I'm saying some value. When I'm changing, this is for some IB, some value of IB. If I increase IB, the IC is increasing. Yes or no? Yes or no?
Yes, sir.
That means your IB is directly proportional to IC. Can we say that? Huh?
Yes, sir.
And your IB change will be in microamperes, remember. But your IC change will be in milliamperes. So this is all milliamps. So see, microamperes is creating a change of milliamperes. Something is there. Something is there. You are giving only one electron, but you are getting 10 electron. We will study in the amplifier. We will try to understand why it is happening like this. Till now it is clear, all of you.
Yes.
Yes.
Yes, sir.
Properly 5 marks you can get easily by writing.
Yes, sir.
So Advait, tell me what is input characteristics. Come on. See the notes and tell me.
Good.
Tell me. See the notes and tell.
Uh,
So you didn't write anything? I'm just हाँ?
प्रीवियस आउटपुट का नहीं लिखा सर, मतलब
क्यों नहीं लिखा?
आउटपुट का डायग्राम ड्रॉ किया।
क्यों नहीं लिखा? मैं बोल रहा हूँ लिखने के लिए, तुम नहीं लिखते हो। मैं जब पूछता हूँ
आउटपुट का रहेगा लिख।
नहीं, बट क्यों? मैं तो टाइम दिया ना तुमको, मैं पूछ भी रहा हूँ ना, तुम लिखे हो कि नहीं लिखे हो। Why you not writing? Harsh, what is the input characteristics? Harsh, Harsh,
Yes sir.
I'm asking you something. What is input characteristics? What happened, Harsh? Have you not written it? Huh? What happened, Harsh? Why not answering?
No sir, I have taken a screenshot of that.
Why can't you write? I am writing, no?
Yes
What about others? Caroline, Siddhi, explain me. What is input characteristics?
Plus the variation of IB versus VBE at constant VCE.
Very good. Very good.
Is the input
Very good.
characteristic.
Very good. What is output characteristics? Caroline? Caroline will tell me. Caroline, what is that?
The variation of IC with respect to VC at constant IB.
Very good. How can we put IB constant?
By keeping voltage constant.
VBE, not voltage. VBE constant.
Really.
Clear? Harsh,
Yes.
otherwise not happy with you guys, huh?
sir.
You have to write, no? Screenshot you take, that's fine. Am I not giving you time to write to you?
Yes.
Then I am writing again and again or not? Or I am teaching you over video, or I am teaching you over PPT, no, right? I'm making sure that I am writing and explaining. If you write only, you will remember. If you don't write, you will not remember. Input characteristics, output characteristics may come one of the very, very important question. You can check previous chapters. Okay.
Okay.
So we will go to the next topic. How is the transistor is used as an amplifier? First of all, what is an amplifier? Anybody? Come on. What is an amplifier? What does the word say? Who will tell me what is amplifier? What is an amplifier? Anybody? Harsh, what is an amplifier? Kalin Siddhi.
Increases the voltage.
Okay. What did you say? Sorry.
Device that increases voltage.
Okay. Okay. Write down definition. This is an electronic device that increases the amplitude of voltage, current, or power. It can be anything of a weak alternating current signal by drawing energy from a separate source other than the signal is called amplifier. Understood? So I am giving this is the AC signal. Sorry. This is AC signal. So this is an amplifier. What does the amplifier do? It will convert into a bigger by not changing, by not distorting. It is not distorting the signal. That doesn't mean that signal became like this. No, signal form is same only. Only thing is that the amplitude, if I draw like this, the amplitude is bigger. Can you see the difference?
Yes.
Only the amplitude is changed. You are getting amplified. So the best example is what? Have you seen a mic system? You will see a box in your schools. There'll be a very big machine where one microphone will be connected, and here the speaker will output will come. Why do you use microphones? Because when you are speaking, only one person can hear. You have to speak to a larger audience. So that more people, the power will be more. You have to make sure that you whatever you're speaking, more people can listen. So what you have to do? You have to use amplifier. Understood? Understood?
Yes, sir.
Yes, sir.
The best example is the amplifier, the microphone. So you can see there, you will see some buttons will be there, volume will be there, gain will be there. You can increase the volume, you can decrease the volume, you can change. So amplifier, the main principle of the amplifier is to amplify the signal, the weak signal into a what? Into a amplified signal by increasing amplitude, by not distorting the original waveform. You are not distorting. This is a sine wave. The sine wave is not getting converted into a triangular wave, neither a square wave. It is just the sine wave remains a sine wave. Only thing is that the amplitude is more. It does not change the frequency also. There is no change in the frequency. Only thing is that amplitude is changed. Understood? All of you?
Yes, sir.
So can you say with me, everybody? Start reading out what have I written? Yes, start.
An electronic device that increases the amplitude of voltage and power of weak AC signal by drawing energy from a separate source other than the signal.
Is called amplifier.
It's called an
You
amplifier.
can write down one more point. A electronic device that increases the amplitude of voltage, current or power of a weak signal by drawing energy without distorting the original waveform. Add here. Here you add without distorting the the form of the original signal. Understood? Hmm? Everybody clear?
Yes, sir.
Hmm. Small man. Have you played, what do you call that? What is that? Macro. What is that game? A one small game is to come to one man is to be there. It is to be big. It will jump and go.
Mario.
Mario. Have you played Mario? Have you seen Mario?
Yes, sir.
So what is there in the Mario? That man, when he takes point, it becomes a big man. Yes or no?
Yes.
So what is only the height is changing? Yes or no? So this is what the amplifier does. The man remains the man. Man is not becoming dinosaur. Understood? Man is becoming man only.
Yes.
Only thing is that height of the man is increasing. Understood? All of you?
Yes, sir.
Yes, sir.
Good. So transistor. For first point, transistor the amplifier. You have to define. You have to how do you write an exam? First you define what is a what is an amplifier. Define amplifier, and then you say transistor. A transistor plays a vital role as an amplifier. Hence, the transistor has to be used in a active state. What is active state? Who will tell me? Who will tell me what is active state? What is active state? Hmm. What is active state? I told you emitter base is in forward biased. Yes or no? And collector base is understood? Yes or no?
Yes, sir. Yes.
The emitter base junction, is it forward biased? Collector base junction, is it reverse biased? This how we will say it is a active. Only when you connect in this one, in this form only, the transistor will amplify, or else the transistor will not amplify. Is it clear?
Yes.
What happened? Sorry, somebody said. What happened? Harsh, anything?
No, sir.
Some sorry I heard. Okay, fine. So let us draw the diagram of a common emitter transistor. Okay. You want to take break? 5 minutes break you want, or you want to continue? Okay, no? Able to understand, right? Yes or no?
Yes, sir.
Okay. So let us draw the transistor as an amplifier. So we'll draw the diagram of a transistor as an amplifier. Clear, guys? Same figure, almost same figure. Yes or no? Hmm? Yes or no?
Yes, sir.
Almost same figure. So what is the signal? Input. You are giving a input AC signal, and here you are getting a, what is this? Amplified output. Am I correct? You are giving a input AC signal, and you are getting a output. What? Same signal, but is a output amplified output. Am I correct?
Yes, sir.
Yes or no?
Yes, sir.
Okay.
Yes,
Good.
sir.
Okay. So what is happening? Hmm? You have to understand what is happening. Come on. So now additional, when I was not using this AC signal and I had VB, so the only current which was the IB was dependent on what? VBB, yes or no? This VBB, okay. The VB is the base and the emitter, the voltage between the base and emitter. The current IB, the input current, is only dependent on the voltage only, VB voltage, yes or no? But at moment I have attached a signal. Now the IB is no more dependent only on VB. Is it dependent on what also? V input. Yes or no?
Yes, sir.
Yes or no?
Yes, sir.
Before the IB was only dependent on VB. Now it is additional. You see the definition what I wrote. Other than the source, that means other than the source, there is an additional VBE also. Now that VBE plus V in is determining the total voltage, the V input. Yes or no? Yes or no?
Yes.
Huh? And that's how
Yes.
that's how the magic is. That is wow. That is how the what? The transistor works. That is how the actual working happens. So I don't want to teach more because there is derivation. So today Aryan also is not there. So I want you to learn whatever has been taught, input output characteristics, and this diagram, draw it, understand it. We will continue in the next class. Next class I will notify in the WhatsApp when there is the next class. Okay, all of you clear?
Yes.
Any doubts?
No, sir.
No, sir. Yes.
Carolyn, clear?
Yes, sir.
Very important. Transistor as an amplifier, input output characteristics, sure short question you may get this or that. Okay, Advait, clear?
हाँ yes sir.
प्लीज इन्फॉर्म आर्यन को बोलना है, बहुत इंपॉर्टेंट है, नेक्स्ट क्लास मिस ना करे, ठीक है?
हाँ हाँ सर, बोलता है सर उसको.
तो ट्यूसडे को क्लास कर सकते हैं क्या? कैन वी हैव क्लास ऑन ट्यूसडे?
Okay sir, no problem sir.
Tuesday 8 o'clock is fine.
हाँ sir, 8 o'clock is fine.
Yes, sir.
Caroline Siddhi, fine.
Yes, sir. Yes, sir. 8 o'clock.
8 to 9 p.m. Okay. So we'll study the amplifier part and we'll end the class with not and gate and not gate, logic gate. Then with that the chapter will be finished. Okay.
Okay.
Okay. Take care. Good night.
Bye.
Bye, sir. Thank you, sir.